the end inspiratory transpulmonary pressure, a gross this is probably more confusing than it should be. A gross underestimate of end inspiratory transpulmonary pressure, a gross overestimate of end inspiratory transpulmonary pressure, unrelated to the end inspiratory transpulmonary pressure. So, you did a plateau pressure in an obese patient, a massively obese patient. You got a number. Is that reflective of the transpulmonary pressure at end inspiration? Let's go on the clock. Whoa! Whoa! We're all over the chart here.
Everything is possible.
Everything is possible. It's an overestimate. It's an overestimate. So when you and I, if I get a plateau pressure of 20, okay, your pleural pressure is less than 5. So it's a close approximation. Okay? If I have a stiff, it's not a stiff chest wall, but if you have this massive weight on the chest that will raise the pleural pressure, that will add to the measured plateau pressure, but it's not adding to the transpulmonary pressure. It's only adding to the plateau pressure. So the plateau pressure becomes way overestimating, a big overestimate of the actual transpulmonary pressure. Okay, everybody clear on that? It looks like there's some confusion here. Okay? Marcelo showed you, what was that, pig with a big claw?
Just to make clear, I've shown that typically in the obese, you don't have too much, let's say, it's not going to affect your transpulmonary driving pressure.
I didn't say, I'm not talking about driving pressure,
Yes.
I'm talking about the plateau pressure.
Plateau pressure, yes, absolutely.
Yeah. Okay? Yes?
Well, in relation to your slide about how Evan Scanner did the study,
Yes.
was that the plateau pressure or that was the driving pressure?
The driving pressure, so it means,
Yeah.
because the chest wall compliance is normal, but you have a big offset of pressures. All the systems, they are at a higher pressure because of the obesity, the weight.
Okay, we're coming to a break here, and I want to make sure Dr. Slutsky gets his allotted time. So I'm going to skip over a couple of these. Those of you who want these slides, the ones I skipped over will be there so you can still look at them. Okay, a patient has the ventilator adjusted from the left to the right panel to improve comfort. What was the adjustment, and did it help? So we've got flow, we've got volume, and we've got airway pressure. And we've made an adjustment to make the patient more comfortable. Did we change the volume assist control and the patient got comfortable? Did we change the pressure support and the patient got comfortable? Did we change the volume assist control and the patient got worse? Did we change the pressure support and the patient got worse? So let's go on the clock. Yeah, good. So, John went through this yesterday. This very sharp, straight line flow pattern is typical for volume assist control. And the airway pressure graphic down here is being sucked downward. This is an uncomfortable patient from flow starvation, flow dyssynchrony. Over here, we've changed to a pressure targeted breath, targeting the same tidal volume, by the way. But now the flow is more variable. Actually, it has a little rounded bump there. And this has allowed the airway pressure graphic to assume a more square wave configuration. So this is a switch to pressure support, and the patient indeed got more synchronous.
Can I ask you a question? Why do we have a rise of the pressure on the end of this?
I don't know.
Or maybe it's a pressure control at least too long time.
Well, it's hard to tell where this breath cycles off.
Yeah.
It's a real patient. They have things that, they have little bumps and whistles along the way. A patient is receiving this mode of ventilation. The thin arrow, right there, represents a weak effort. The thick arrow represents a big effort. And that's because in the esophagus you can see very small deflection here, very large deflection here. What mode behaves like this? Proportional assist, volume support, volume assist control, pressure support, APRV. So there's flow, there's airway pressure, and there's change in volume. So let's go on the clock. Bingo. Proportional assist. Little bitty effort gives little volume, little flow, and little airway pressure. Great big effort, lots of volume, lots of airway pressure, and lots of flow. I think you guys got that one. A patient is receiving pressure-controlled ventilation and low-volume alarms are sounded. Which of the following tracings is most consistent with mucus plugging? So this is PCV. There's the baseline on the left. A, B, so there are only three answers here, A, B, or C. Which one is mucus plugging? Oh, down the clock, good. So most of you like A, and A is the correct answer. So, it's pressure control, so the pressure stays exactly the same. In a mucus plug, you're going to lose the tidal volume, as you do in A and B. In C, what you got is a big leak. So the tidal volume is lower, but it's because you're leaking it. So how do you differentiate between a bad compliance or a bad resistance? Same pressure, same volume, you look at the flow signal. And here we have a very reduced expiratory flow that takes a long time to empty. Here we have a very sharp expiratory flow, very rapid entry. This is a compliance issue, this is an air resistance issue. Compliance worsens between A and B. What mode behaves like this? And the choices: proportional assist, SIMV, pressure support, PRVC, volume support. Let's go on the clock. John, which one is that? D? Yeah, it is pressure regulated volume control. So here we go, square wave of pressure, decelerating flow with a little curvature on it, typical of a pressure breath. Over here, we've lost tidal volume and flow, or volume and flow, and what is the ventilator doing? It's jacking up the airway pressure over the next couple of breaths to restore the tidal volume. Let me skip a couple. Oh, I had that one again. Let me make sure I got all the ones on it. I want to make sure we have time for our break. Oh. Yeah, so we'll quit there. It's break time. I want to make sure we all get a chance for coffee. Art will follow at 4:15, excuse me, 3:15.